Okay, we're just going to look at some multi-stage events. So we're going to do these ones. These ones are all like independent of each other. So that means like the first one doesn't affect the other one. So we're just going to do a coin. If we toss a coin twice, what's the probability of getting at least one head? So it'll be 1 minus the probability of no heads. So no heads would be probability of a tail and a tail, because we did it twice. So it's 1 minus a half times a half, which is 1 minus a quarter, which is 3/4. We could also list it out, but we're going to try and avoid that and use these rules here at the top. Sorry, I forgot to go through those at the start. So the probability of A and B is the probability of A times B. And the probability of C or D, assuming that they are separate events, is the probability of C plus the probability of D. Like there's no overlapping like you would have like in a Venn diagram. Okay, so we're doing two separate things. So we're doing the first event and then the second event. So we could either get this or we could get this, and there's no overlap. So that's why you can actually add them. Okay, so independent, they're called independent events. These ones, when I'm looking at two coins, it could be like a dice, because every time you do it, what you get on the first row doesn't affect what you get on the second. It's the ones that do is where you do stuff without replacement. Okay, so if we were writing out all the options here, to be a head, 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 tail, tail, head, tail, tail. Okay, but we're not going to do it that way. We're going to try and just use these rules up here. Okay, so Jack and Jill go for a driving test. Jack has 80% chance of passing and Jill's 75% chance of passing. What's the probability that they both pass? Now, let's just have a look at something. I'm going to put Jack can be A. So if Jack passes, that would be, I'll put it as 0.8, because 80% is just 0.8. It's just easier to write it as a decimal, I feel. And B, so this is Jack is A and Jill can be B. So Jill would be 0.75. So Jack not passing, if I put the line on top that represents not, that would be 0.2. And Jill not passing would be 0.25, because these have to add up to one whole. 0.25 and 0.75 is 1. And 0.8 and 0.2 is one whole. Okay, so they both pass, so that would be the probability of A and B happening. So that'll just be the probability of A times the probability of B. So the probability of A is 0.8 and the probability of B is 0.75. So you just multiply those together to get your answer. And you just end up with 0.6, which is, as a percentage, 60%. Okay, so the second one, probability that only one passes. So Jack could pass and Jill not, or Jack could not pass and Jill could pass. They're your two different options. And you could see that if you did want to draw a probability tree, it would be Jack passing, Jack not passing. Jill passing, Jill not passing. And that helps to give all your options if you can't think about them. Okay, so the probability Jack passes would be 0.8 and Jill doesn't pass is 0.25. Or, so these are two separate events. That's why I can add them together. And Jack not passing is 0.2, Jill not passing is 0.25. So that works out to be, sorry, just a correction on the second one there. That should be, I wrote 0.25, it should be 0.75, because you want Jack not passing, but you want Jill passing. And you end up with 0.35, which is 35%. Okay, so now we're just going to look at the third one, which is at least one passing. So the probability, if we do at least one passing, that will be 1 minus the probability that none pass, like neither of them pass. So that's 1 minus, so Jack doesn't pass, so that's A, and Jill doesn't pass. So that's 1 minus 0.2 times 0.25, and you get for that, you end up with 0.95. which is 95%. Okay, and just at most one pass, so the probability at most one passes would be the probability that none pass, because at most one means you can't have two of them passing. You can have none of them passing or one of them passing. Or you could have one pass. So one pass could be Jack pass and Jill doesn't, or Jill passes, Jack passes, and Jill doesn't. So we've actually already done that option. If you go back up to this one here, we've actually already done that there. So instead of that, like none passing, we've also done that somewhere, I think. Oh yeah, we did up there. It's 0.2 times 0.25 plus we calculated both of them, only one of them passing, not the top. We ended up with 0.35. So when you add those together, you get 0.4, which is actually as a percentage, that would be 40%. Okay, so let's look at this question. So Daniel and Adam are playing a tennis tournament. They will play each other exactly twice. For their first game, each player has an equal chance of winning. So we're assuming that they don't draw. Okay, so you could have Daniel win and Adam, or Adam wins, because if Daniel wins, Adam loses. Okay, so Adam win, so they have an equal chance, so that's 0.5, 0.5. However, if Adam wins the first game, now what I might do, if Adam wins the first game, so that's this one here, then the probability of winning the second game would be 0.55. So Adam wins would be 0.55, and that would be Daniel would have to lose. Now, if Daniel wins, so that would have to be 0.45. So if he loses the first game, if Adam wins the first game, if he loses the first game, so that would mean this one. So this is if Adam loses. If Adam loses the first game, then the probability of winning the second game is 0.35. So this would be Adam winning, and that would be 0.35, and this would be Daniel would have to win. So that would be 0.65. Okay. Now, I'm probably better when I'm drawing this. I might just redo it just to show you. Like, that's one way of doing it, but I might just show you that if we just focus on Daniel, for example, or we focus on Adam. Let's focus on Adam because they do talk about Adam. So Adam could win or lose on the first game, or win or lose. This just simplifies it a bit better. So Adam's chance of winning on the first game is 0.5 and losing is 0.5. Now, if Adam loses on the first game, then he has a 0.55 chance of winning on the second and 0.45 of losing. If he loses on the first, I haven't done that the right way around either. If Adam wins on the first game, he has a 0.55 chance of winning and a 0.45 chance of losing. But if he loses on the first game, his winning chances go to 0.35. So that means this would be 0.65 because it's got to make up one whole. And how am I getting these ones here? It's because the 0.55 and the 0.45 have to equal 1, 0.35 and 0.65 have to equal 1. And the 0.5s come because it said at the start that they have an equal chance of winning. Okay, so let's see if we can do the questions. Find the probability that Adam wins exactly one game. So that would be along that tree or along that one. So one game would be 0.5 times 0.45 because he wins on the first but loses on the second. Or he could lose on the first and then he could win on the second one. And you end up with 0.4. Okay, so that would be 0.4 for that one. All right, what's the probability that Daniel wins at least one game? So do 1 minus the probability that Daniel wins at least one game. So if Daniel is going to win at least one game. We've got to be careful here, because I'll do a separate probability tree, because I think it'll be less confusing. So Daniel, or we could just try and use that one. Let's just think about it. Find the probability that Daniel wins at least one game. That would be the probability that Daniel would lose and lose. Now, for Daniel to lose and lose, that would be the same as Adam winning and winning, wouldn't it? So I could actually get it from this tree. Okay, so if Adam wins, it's 0.5 times 0.55. Okay, so yeah, it can get a bit confusing when they're switching from one to the other. So that's 0.725. Okay, so find the probability that the same person wins both games. So that's the probability that Daniel wins, or Adam wins and Adam wins. Now, for Daniel to win twice, that would mean that Adam would have to lose twice, and then that's win twice. So for Adam to lose twice, that would be 0.5 times 0.65. And for Daniel to for Adam to win twice would be 0.55 times 0.55. Okay, so you end up with 0.6.